Hi everyone, what's up? Today I'm going to show you how to solve this problem up here. So in this problem we have 3 points where we have known coordinates and we need to find the equation of the plane containing these 3 points, okay? So first of all, let's make a diagram of this situation. So we're going to have, let's say this is going to be the plane that we have. Yeah, that works out. So we're going to have 3 points and I'm going to say this is going to be P1, this will be P2, and these will be P3, okay? So now let's say this is gonna be P1 down here. It doesn't really matter where you write the points. They're just gonna be in space and you can just write them anywhere. In this diagram, it's not relevant. So this is gonna be P1, P2, and P3. And we need to find the equation of this plane containing all these points, okay? So there is a very important equation that I will use, which is called the point norm form of a plane, okay? And it goes like this. So 0 is going to be equal to a times x minus x naught plus b times y minus y naught plus c times c minus c naught, okay? So now this is the point normal form of a plane because we're given a point, so x naught, y naught, and c naught, they're gonna be the coordinates of a point in a plane, and a, b, and c are gonna be the components of a normal vector to the plane, okay? So remember, all planes, they have a normal vector, which means they have a vector that is perpendicular to the plane, okay? So a, b, and c, they're gonna be the components of the normal vector to the plane, and x naught, y naught, and c naught are going to be the coordinates of a point within the plane. Now we have 3 points within the plane that we're trying to find, which is really good, meaning we already have x naught, y naught, and c naught, and the only thing that we need is a, b, and c. Now if we're given 3 points, how can we find a, b, and c? Well, remember, a, b, and c, they're going to be components of a normal vector. Now how can you find normal vector first? Well, if you have a normal vector, that means that you have a vector that is perpendicular to 2 other vectors contained within a plane, okay? Because if you take the cross product of 2 vectors, you're gonna get a vector that is perpendicular to the plane of those 2 vectors, okay? Hopefully that's an idea that's clear in your head. Now, that's exactly what we're gonna do. We're given points and we can build vectors off of points. So the first thing we're gonna do is we're gonna pick an origin. I will say, let's just say P1 is gonna be our origin. And we're going to have the following vector. So we're going to have a vector that goes to P2, and then we're going to have a vector from P1 all the way to P3, okay? So these are the vectors that we have, P1 to P2 and P1 to P3. Now we know P1 to P2 and P1 to P3, they will be contained in the same plane. Now what does that mean? Well, we want a normal vector to a plane. If you take the cross product between P1 and P2 and between P1 and P2 and P1 to P2, sorry, and P1 to P3, if you take the cross product between those 2 vectors, you will get a vector that is normal to this plane, okay? Which is exactly what we want, so that's what we're going to do. So there is going to be a vector, which is going to be something like this, and I'm going to call it n, okay, normal. And we know n will be perpendicular to our plane. And now how can we find n? Well, we know n is going to be, so n, we know it's going to be simply the cross product of the vectors. So we have P2 to P1 cross P1 to P2, I said it the other way around. P1 to P2 cross P1 to P3, okay? Now first of all, before doing this operation, we need to find P1 to P2 and P1 to P3. That's very easy because we have the coordinates of the origin and the head of the vector, and then we can just simply subtract each set of coordinates. So we're going to have the coordinates of point 2 minus the coordinates of P1, and that will be the components of P1 to P2. So we have P2 minus P1, so that's going to give us an x component. So we have 0 minus 1, that's going to be minus 1. Then we have 0 minus 2, that's going to be minus 2. And then you have 3 minus 3, that's going to be 0, okay? And we do the same thing for P1 to P3, okay? So this vector, we know, we can just simply subtract all the coordinates. So we have 2 minus 1, that's going to be 1. Then we have 5 minus 2, that's going to be 3. And 5 minus 3, that will be 2, okay? 5 minus 2, 5 minus 3, yep, that works out. So now we just simply need to take the cross product between these vectors. So we're going to get that these will be equal to, should I write? Now you already know what we're going to do. So I'm going to do a Laplace expansion with respect to the first row. And the first row is just going to be unit vectors. So I hat, j hat, and k hat. And then I'm just going to plug in here the components that we have. So minus 1, minus 2, and 0. And then 1, 3, and 2. We know this is a way in which you can compute cross products. And then we just simply need to take the minors of this matrix, okay? So then we're going to cover this column and this row, the upper row, and then we're going to take the determinant of this sub matrix, if you want to call it that. So then we know that we're going to have, so minus 2 times 2, that's going to be negative 4, and I'm actually going to write out the entire thing. I don't want to make silly arithmetic mistakes. So we have minus 2 times 2, and then minus 3 times 0, that's going to be 0. So then we just get minus 4 times I hat. Then we're going to have minus for the component of j hat. And then we just simply take the minors of minus 1, 1, 0, 2. So we have minus 1 times 2, that's going to be minus 2. Minus 1 times 0, that's going to be 0. So then we just have k hat here. Oh, sorry, j hat, not k hat. This will be j hat. It's going to have plus 2 as component. And then we do the component of k hat. So we cover the upper row and then we cover the rightmost column. So we're going to have minus 1 times 3. That's going to be minus 3 minus minus 2. So that's going to be minus minus. That's going to be plus. So then we have plus 2. And this is the component of k hat. Okay. Now what does this mean? Well, we're going to have that n is going to be equal to the following. So minus 4, that's the I hat component. Then we have plus 2, that's the j hat component. And then we have minus 1, that's the k hat component, okay? Was that minus 1? Minus 3, minus plus, yeah, plus 2, yeah. I just got like a flashback to a problem I did where like I had minus 3 plus 2 and I screwed up somehow. Anyways, yeah, this is negative 1, yeah. So n is going to be equal to this vector. We have the components. And this, we know, is going to be the a, b, c values that we need. So it's going to be a, b, and c, okay? And then that means that, well, we can now plug these values into this equation. And we can just choose any arbitrary x naught, y naught, and c naught. So P2 looks really nice because we've got zeros here. So x naught and y naught, they're going to be really easy to deal with. So yeah, let's do that. So we're going to have the following. We're going to have, this is going to be the equation of the plane. We're going to have 0 is equal to a times x. We know a equals negative 4. So it's going to be minus 4x. Now I'll do the constants in the end. So we have b times y. We know b is going to be 2. We have plus 2y. And now we have c. We know c is going to be negative 1. So this will be minus c, and now let's do the constants. We have a times minus x naught. We know it's going to be 0, so we don't write anything. B times negative y naught, that's also going to be 0. And then we have minus 1 c times minus c naught, or z naught. So we know z naught is going to be 3. So then this is just going to be minus 1 times negative 3, that's going to be plus 3, okay? And this means that the plane equation that we want, yes, I'm going to multiply everything by negative 1, is going to be 3 is equal to 4x minus 2y plus c. Yep. The signs should be right there. Yep, they are. So this is the equation of the plane that we just found. Now, of course, you could find variations or scaled up or down versions of this plane if you pick a different normal vector, or if you have if you pick a different x naught, y naught, and c naught, you're gonna get different plane equations, but they all work out. They're all the same plane equation, okay? So yeah, this is a possible answer. Depending on what point you choose, you're gonna get different forms, okay? But this is one that will work, okay? And then we can see if it works actually by plugging in some values. So let's just real quick, yeah, let's try out. Let's do P1. So we know we should get that 3 is equal to 4 times 1, that's going to be 4, minus 2 times, so minus 2 times 2, that's going to be minus 4, and then plus c, or z, we know it's going to be 3, so this indeed checks out, okay? So this plane equation works out nicely, okay? And you can also see that if you plug in P2, you also get 3, and if you plug this, you're also going to get 8 minus 10 minus 2, plus 5 minus 2 plus 5, that gives you positive 3, okay? So all these points lie within this plane, okay? So we're right. That's been the entire video. Hopefully you enjoyed it. This is a very nice problem. It's really easy, really. As long as you know this form, and you know how to take a cross product, and you know how to find vectors given points, you're good to go, okay? So yeah, that's been the entire video. Hopefully you enjoyed it, and bye.